VLAN 10 computers will be connected to the first 8 ports on each switch. All of the green VLAN or VLAN 20 computers will be connected to the second 8 ports on each switch. On these three switches, the first 8 ports on each switch will be joined into VLAN 10, and the second 8 ports, so from fast Ethernet 0/9 to 0/16, they will belong to VLAN 20. Another thing that is new in this exercise is that most of the configurations that we have learned earlier have already been set. So IP addresses are already assigned to PCs. Host names are already configured according to the diagram below. Rapid PVST is already configured on all switches and MLSs. The configuration is exactly the same as before as on regular layer 2 switches. Access ports with port fast are already configured according to this topology here, and trunk ports are already configured on all 2960 switches. The only trunk ports configuration that is left for us to do is on MLSs, because it is a bit different compared to the regular layer 2 switches, and I will show you that right away. That is the first thing we will do. So in order to configure trunk on MLS interfaces, you need to define the encapsulation. That's pretty much the only difference there is. Second task, configure VTP. We have already done this, but let's do it in this exercise as well. We need to configure root bridge for both VLANs, and we're going to have the same root bridge for both VLANs. It's going to be MLS1. Configuration for this is again the same as before. And then the last task is to configure MLS1 as a gateway. This will be quite a novelty for us, so we will pay attention to that one. Let's get going. The first thing we need to configure are trunk interfaces on both multi-layer switches. I'm going to say enable configure terminal, get right into those interfaces, interface range gigabit Ethernet 0/1-2, and then switch port trunk encapsulation .1Q. So this is the full command. And then we can just say switch port mode trunk. We have one more trunk interface, fast Ethernet 0/24, and we will use the exact same commands on that interface as well. Switch port trunk encapsulation .1Q, and then switch port mode trunk. Let's go to MLS2. Enable configure terminal, interface range gigabit Ethernet 0/1-2, switch port trunk encapsulation .1Q, switch port mode trunk. Interface fast Ethernet 0/24, switch port trunk encapsulation .1Q, switch port mode trunk. That's it for the first task. Let's go to VTP. MLS1 will be a server and all others will be clients. Let's configure the server first, and then we can cheat a little bit with Notepad as we used to do earlier. So VTP mode server, VTP domain cyber, VTP password cyber. Let's create VLANs. No name, but VLAN 10, name purple, and then VLAN 20, name green. Now for VTP clients, on each of the other switches, I will need to type in enable, configure terminal, VTP mode client, VTP domain cyber, VTP password cyber. I'm going to copy that and paste it into the command line. In MLS2, I've already entered the global configuration mode previously, so it's not going to recognize the enable and configure terminal commands, but that shouldn't bother us since all of the other commands were accepted anyway. So let's move on to switch D1. I'm going to say paste. Once you're done pasting these commands, maybe press this fast forward time button, and then we can get into some of the switches and issue the do show VLAN brief command to check if these VLANs have been created on all switches. We can see here that these VLANs do exist on this switch. Let's check some other switches, for example, this one. Yep, they are here. And then we can maybe check S3. Since on S3 we only have VLAN 10 computers, so we should see VLAN 20 here as well. Sorry, I have joined all of the interfaces, so on all three switches I have joined the first 8 interfaces into VLAN 10 and the second 8 interfaces into VLAN 20. So the green VLAN 20 does exist on this switch, and it did exist prior to VTP client configuration because I did join these 8 interfaces into that VLAN. So my apologies, let's move on. Our next task number 3, is to configure root bridge for both VLANs, and that's going to be MLS3. The command is quite simple here. It's spanning 3, VLAN 10, root primary, and then I'm going to use the up arrow and switch 10 into 20. The spanning tree algorithm might recalculate the tree here, but that should not bother us. We can move on with task number 4. Task number 4 says that we should configure root guard on MLS1 on interfaces facing the distribution layer switches. Those are the dist1 and dist2 switches. Those interfaces on MLS1 are Gigabit Ethernet 0/2 and Fast Ethernet 0/24. So let's start from Gigabit Ethernet 0/2. We shall say spanning tree guard root. And then interface Fast Ethernet 0/24, spanning tree guard root. That's it for task number 4. On to task number 5. This one is a bit more complicated because this is completely new stuff for us. In order to have a multi-layer switch, that's right, this is still a switch. In order to have a switch perform routing, which is what is needed in a gateway, so if we need these two VLANs to communicate in between each other, MLS needs to route that traffic between those two VLANs. That is not quite natural for a switch, so there is a command to make it do routing, and the command is luckily quite simple. It's just IP routing, but we also need to create some kind of interfaces on this switch because we need some place to configure a gateway IP address. I'm going to first show you all of the commands in the exercise guide. So unlike on router on a stick, where we use physical interfaces to create virtual interfaces or virtual sub-interfaces, on a physical interface, here we are going to create a completely new virtual interface, and that interface is going to be a VLAN interface. I know it sounds simple, but my students used to mix those two up all the time. So once more, when you have a router and you're configuring router on a stick, you will use a physical interface, so fast Ethernet or gigabit Ethernet interface, and then create sub-interfaces. On a switch or on a multi-layer switch, it doesn't matter, you will create a VLAN interface. It's still a virtual interface, but you don't use or need any physical interfaces to configure this virtual VLAN interface. Let's configure that on MLS1. So interface VLAN 10. As any regular physical interface, you will have a state and you'll be able to see what is the state of that interface. Right here we can see that as we created this interface and this VLAN exists on this switch thanks to VTP, line protocol goes up, which means that this interface is now switched on. In case you missed to configure or create VLANs on a switch where you are creating this VLAN interfaces, this will not happen. So you won't be able to bring an interface up if you don't have that VLAN already configured on your switch. So those things are related. Okay, now that we have created the interface, we're going to assign an IP address to it. And this is a mistake. So it should be .1. Sorry about that. So for VLAN 10, it's going to be 192.168.10.1, and then /24, of course. And that's it. No need to type in no shutdown here because it's a virtual interface and it is already up. As soon as you create it, it's going to be up. Let's create the second one. So interface VLAN 20. IP address 192.168.20.1/24, and that's pretty much it. We've already configured IP routing, so we can go straight into testing. Let me just check if the gateway has been configured on PCs. Yes, it has. Not on all PCs. Okay, I will make sure to fix that in your clean packet tracer file, but I will fix it right now in my exercise, so it's going to be 1. Great, let's see if the communication works. As always, this window is quite small. Okay, let's first try the communication between two PCs in the same VLAN. That works, that's a good sign. Let's try PC4 to PC5, PC7 to PC3. I'm gonna clear this out. And the next logical thing to try is connectivity between PCs and their gateway. And then the last thing to test is connectivity between PCs that belong to different VLANs. As always, first 1 or 2 or sometimes even 3, depending on the size of your network. First couple of pings may fail, but eventually if ever get a successful status right here. Let's try some more between PC3 and PC4. Again, we'll get right into the exercise and I'll explain the new commands as we go. Let me explain the topology and our goals for this exercise before we start. First of all, we have two MLSs here. But what is different this time is that there is a layer 3 link between them. This means that these two networks are completely separate. The VLANs in the network on the left, 10 and 20, have nothing to do with VLANs on the right, 30 and 40. They only matter locally. This means that once a packet from VLAN 10 reaches MLS 1 and MLS 1 sees that it wants to get out of that network, say PCA wants to send something to PCF, MLS 1 will remove any VLAN information from that packet and send it to MLS 2. Once MLS 2 receives that packet, it will have no clue what was the original VLAN that packet came from. So how will we actually configure these devices then? Let's start from MLS 1. On the left, on these interfaces where switch 1 and switch 2 connect, Gigabit Ethernet 0/1 and Fast Ethernet 0/24, on that side, MLS 1 is a layer 2 switch. There, we will configure trunk. On the right, on Gigabit Ethernet 0/2, we will configure an IP address. And to do that on a multi-layer switch, there is a specific configuration. The specific configuration is actually only one command. Once you get into interface config mode, you type in no switch port. And the logic here is similar to no shutdown. Word switch port is related to layer 2 stuff. So if you switch it off, so to say, you get layer 3 stuff, including the IP address. After no switch port, you can just configure the IP address the same way you would on a router. Next, to use an MLS as a gateway, you need VLAN interfaces. But we already learned that in the previous lesson, so we will repeat the same thing. And finally, if we want the network on the left to be able to communicate with the network on the right, we need routing, because MLS 1 isn't aware of the networks connected to MLS 2. We will create simple static routes. I'll explain them here only briefly, but there will be a lesson later on both static and dynamic routing. Let's go through this first command. IP route is in the beginning of the command, that's clear. Then there's a network IP and a mask. That's the remote network that your router, or in this case MLS, will use this route for. And then there is the next hop IP address. In this case, that's 192.168.102. This IP address will be configured on MLS 2, so that's this link between MLS 1 and MLS 2, and we will set 192.168.100.1 on MLS 1 and 192.168.100.2 on MLS 2. So in this command, we're telling the router, if you get a packet whose destination IP belongs to this subnet, send it to 192.168.100.2, meaning send it that way. Okay, let's start the exercise and I'll explain this further in a simulation. The first thing we are required to do is configure host names and a banner with your name on MLS 1. Let's start with switch 1. Enable configure terminal hostname S1. MLS 1 enable configure terminal hostname MLS 1, and then banner message of the day Cyber Quince. Switch 2, same commands, enable configure terminal hostname S2, Enable configure terminal, hostname MLS2, switch 3, hostname S3, and then switch 4, enable configure terminal, hostname S4. Next, we are required to configure access interfaces. So on switch 1, that's going to be interface fast Ethernet 0/1. Switch port mode access, switch port access, Vlan 10. Exit. On switch 2, interface F0/1 is switch port mode access, switch port access, Vlan 10. And then fast Ethernet 0/2 is in Vlan 20. We won't be configuring any of the STP stuff in this exercise because we do not have any loops here. Let's move on to switch 3. So interface F0/1, switch port mode access, switch port access, Vlan 30, and then F0/2 is in Vlan 40. On switch 4, we have interface fast Ethernet 0/1, switch port mode access, and that one belongs to Vlan 30. Next, we need to configure trunk interfaces, and those will be all of the interfaces between the switches, including MLSs, except between the two MLSs, because this link is going to be a layer 3 link, and layer 3 links are neither trunk nor access. So gigabit Ethernet 0/1, switch port mode trunk. And then on MLS 1, 0/1, switch port mode. Oops. So on an MLS, we actually have to use the encapsulation command. I almost forgot about it. So trunk encapsulation.1q, and then switch port mode trunk, and then the same command on fast Ethernet 0/24, switch port trunk encapsulation.1q, switch port mode trunk. On MLS2, gigabit Ethernet 0/1, switch port trunk encapsulation.1q, switch port mode trunk. Interface fast Ethernet 0/24, switch port trunk encapsulation.1q, switch port mode trunk. On switch 3, we only have gigabit Ethernet 0/1. Let me check that. Yes, it's 0/1, switch port mode trunk. And then on switch 4, fast Ethernet 0/24, switch port mode trunk. Task number 4, manually create missing VLANs on switches in both networks. The reason why we will not use VTP in this case is because we have a limited number of switches, and we also have only 2 VLANs in each network. So we are missing VLAN 20 in switch 1, so I'm just going to say VLAN 20 and then exit, and on MLS 1 I will just create the 2 VLANs, so VLAN 10 and VLAN 20. And then on MLS 2 I need VLAN 30 and VLAN 40. On switch 3 I have both VLANs, and on switch 4 I'm missing only VLAN 40. Next task, configure both MLSs as gateways for their own networks. So we need to do several things here. First thing is to enable IP routing so that we can use this MLS for IP routing or to add any kind of IP addresses. So I'm going to say, I'm going to say IP routing first. And then let's create VLAN interfaces. So it's going to be interface VLAN 10. And define the IP address. That's going to be the gateway IP for all of the computers in VLAN 10. That's 192.168.10.1 with a C+ mask.
That's 0.
Next is interface VLAN 20. IP address 192.168.20.1 255.255.255.0 and then exit. Let me do the same thing on MLS2 before I configure this layer 3 link. So on MLS2 I need first IP routing and then interface VLAN 30. IP address 192.168.30.1 255.255.255.0 and then interface VLAN 40. IP address 192.168.40.1 255.255.255.0 exit. Now onto this layer 3 link. I'm going to go into MLS1 and this time we are actually going to open the physical interface, and that is Gigabit Ethernet 0/2. I'm going to say no switch ports and then simply assign an IP address. That's going to be 192.168.100.1 with a /24 mask, so that's 255.255.255.0. And then on MLS2, interface Gigabit Ethernet 0/2, no switch ports, IP address 192.168.100.2 /24. Now I can even try to ping the neighboring IP address, so I'm going to say do ping 192.168.100.1. And we got 4 out of 5 successful pings. That's pretty good. And the only thing left to do now is to establish the communication between these two networks. First, I'm going to check if these computers can communicate in between each other and with their gateways, and then we will add those static routes. Okay, so PCA to PCB, that should work. And then PCA to PCC, that's working as well. And then PCA to its gateway, successful. PCC to its gateway, also successful. Let's check the other side. PCD to PCE, successful. PCE to gateway, also successful. On to static routes now. I'm going to look at the topology from here. Okay, so I need MLS1 to be able to reach these two VLANs over here, or these two subnets over here. MLS1 doesn't really care about the VLANs in this network, as that network is a remote network for MLS1. All I need on MLS1 is guidance on how to reach this network over here. So I need to tell MLS1, in order to reach these networks, send the packets destined for this network to your neighbor MLS2. So IP route, and then type in the network you want to reach. So the first network I want to reach is 192.168.30.0, and then the mask for that network is /24, and then the next hop for that network is MLS2, and MLS2's IP address is 192.168.100.2. In one of the following lessons, you will learn that you don't actually have to use the next hop address. You can also use the outgoing interface, so in this case, Gigabit Ethernet 0/2, but there are differences. I'll explain that later. For now, let's use the next hop IP address. Next route, the only difference is actually the third octet in the destination network, so I'm just going to change it like this, and that's pretty much it. We can go on to MLS2 now. Here I need to explain to MLS2 how to reach these two networks on the left, so let's do that. IP route 192.168.10.0, 255.255.255.0, and then the next hop address. In this case, MLS2, when it wants to send packets to this subnet, it will send them to MLS1. And the IP address of MLS1 is 192.168.101. And then to add a route for network 20, I'm just going to do it like this, and that's it. Let's see if it works. PCA to PCD, successful. PCB to